I will move to the next R also. Okay. So I will take the next one also. So what I will do is that so I will split about these two lasers. Okay, go down this about these lasers.
Students are able to see the PPT which I am sharing. Ma, are you able to see
Yes,
PPT
ma'am.
Yes,
which I am
ma'am.
sharing? Hello?
Yes, ma'am. Yes, ma'am.
Everybody come. Hello?
My voice is audible to all, ma.
Yes, ma'am.
My voice is audible
Yes,
to all.
ma'am.
Yes, ma'am.
Audible, ma'am.
Correct? No one is responding.
Yes,
Audible,
ma'am.
ma'am.
Audible, ma'am.
Students are you able to hear my voice?
Yes, ma'am.
Yes, ma'am.
Okay. Hey, ma. Only very less students are joined. Nita, a lady. Today morning, how many members were there in the class?
40.
So you can note down all these questions also one by one. So you can take this slide from this slide. Okay, these are the most important questions. Start with this, students, you can take these questions and answers and then go to the, I will go one put on the slides related to lasers and laser. So I will explain one by one. Okay.
Yeah, students. Today our topic of discussion is ruby laser and helium neon laser. Okay. So last class, I think we have discussed about block diagram of laser. Did we discuss or not? Just check
Yes,
your
ma'am.
books. I think we have discussed block diagram of laser. Hey, someone respond, ma. I'm asking you something.
Yes,
Did we
ma'am.
discuss block diagram of laser? How many parts are there in laser system? If no
Three.
one, what ma?
What are the questions you
Three
got?
parts, ma'am.
3 parts, right? What are they? Active medium,
Active medium, energy
source of
and
energy,
resonance
yes.
activity.
Third one is optical resonator. Okay. Now, based on that laser system, we are going to discuss 2 types of laser. First one is ruby laser and second one is helium neon laser. So first is our ruby laser. I want all of you to take this figure in your notes. All of you copy this figure in your notes. Take this construction figure. I want all of you to copy this figure. I hope you all are copying. Draw this construction of ruby laser. Then I'll explain you about ruby laser. Then we'll try to see how it will work based on energy level diagram.
we are going to discuss about biodegradable polymers. Biodegradable polymers. So only some polymers are biodegradable, not all the polymers. So discuss what are the biodegradable polymers. Because after using plastics, we are going to outside, okay? So that polymers are not undergoing.
I hope you are copying, all of you. I'm taking this figure.
So not decomposing. So that
Who are the participants now? Let me see who are the participants. No one is responding. Roll number 42. 42.
Not yet completed.
Whoever is alert in the class, raise your hands. Those who are alert in the class, raise your hands. Roll number 1, 29. Sai Kumar. B. Sai Kumar, change it to your roll number. Rename yourself to roll number. Then Kushal, 14, 15. Roll number 4, 3, then 10. Nita Lintenga. Only these members are alert in the class. What about the others? Whoever has joined class, I want them to raise their hands so that I can know whether actually you are alert in the class or just on because only 13 students are alert. Remaining students?
Ma'am, base clinic.
Now, I want all of you to draw this figure in your notes. Draw it fast so that we can discuss about this working.
So biodegradable polymers are degradation of polymers, that is decomposition of polymers caused by fungal bacteria or fungal bacteria that are easily compostable. So they yield. So what they are taking the products here, they yield CO2, H2O, inorganic compounds, so etc. without leaving toxicity. So that only I get here also. The biodegradable polymers are special class of polymers that break down after its intended purpose by the active decomposition process. These are natural byproducts. So what are the byproducts? After decomposition of the polymer, we get gases, CO2, water, biomass, and some inorganic salts. So biodegradability is transformation by enzymatic action of bacteria. So it's what we do with the further degradation. So by the presence of this bacteria, in the decomposition of bacteria, in the decomposition of that form and can get to the byproducts. So what is the definition? Polymers by enzymatic action of naturally occurring microorganisms from bacteria or other polymers. So what is biodegradable polymers? So you can write to the polymers, it's real. The polymers.
Students,
Polymers. So which degrade by enzymatic action of naturally occurring microorganisms and bacteria are called biodegradable. So biodegradation of polymers not only plastics but also compostable bags like traditional paper bags. So very important to have polymers. And then we have a byproducts in terms of chromas. They use they use capture
Just I'm giving you idea how to draw this figure, that's all. Otherwise, you try to copy whatever I have kept it in the slide. Okay, students. Just for you to make easy to copy, I'm drawing this figure again. I'm not comfortable with this digital slate, but somehow I'm trying to manage it. Okay. So over, so I have taken this figure.
కోరమని తెలిసి వచ్చింది ఇలా పేరు పెట్టుకుంది పేరు పెట్టుకున్నారు పేరు చేస్తున్నామా
Actually, this is our figure, and this one is so this is about our figure. So all of you have copied it. I think roll number 11 has completed. What about others? So shall I change the slide? Yes, students. Shall I change the slide?
Yes, ma'am.
All have completed?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Still who has to complete? Come on. Changing slide, ma. Students, shall I change slide?
Yes, ma'am.
Okay, ma'am.
So after this, you people write down this, then I'll explain you about this figure. Yeah, this one. All of you copy this. What are the three main parts? Here I should write about the slowly crystal rod. After you finished taking the drawing, this part you copy in your notes. So if you take ruby, composition is Al2O3 plus 0.05% of chromium. So take this three in your notes. And here one point you have to add is so all of you copy these three main parts. Then we'll discuss about the construction of ruby laser. So there are three parts: active medium. But what is the active medium we are using? Cylindrical rod of ruby crystal. And what is the composition of ruby crystal? Aluminum oxide plus 0.05% of chromium oxide. And but of this aluminum and chromium, which is the active material is chromium ion. And then pumping system. So this pumping system, it is also called energy source. So this is also called as source of energy. This is also called as source of energy. And third part is optical resonator.
Disturbance also.
If you are done with this, then tell me. Then first we are going to discuss about construction of ruby laser. Then we try to explain it using energy line diagram.
మెల్లగా
Finish, students. Have you taken this? You're not able to hear me properly. Now? Now are you able to hear me?
Yes, ma'am.
నీ మధ్య చాలా డిస్టర్బెన్స్ వస్తుంది.
Shall, is it clear? Still disturbance is there.
ఎస్ మ్యామ్.
See, once you are done with this copying, I'm going to explain about the construction. Have you copied these three main parts of ruby laser?
Yes, ma'am.
Copied, ma'am. See this voice, it is coming from my background, Okay, because another class is going on in my background. You people try to concentrate on my voice. I think all are in mute only. Okay. But is my voice audible? Are you able to hear my voice? Just you focus
Yes,
on my
ma'am.
voice.
ఎస్ మ్యామ్.
Okay, students. So now I'm going back to our construction slide and we'll see what is this ruby laser. Now all of you see here now. When you look at this figure, so every laser system, it consists of three main parts. So active medium, energy source, and third one is optical resonator. So when we talk about active medium, so here we just look at the active medium, students. Actually, this ruby laser, it is called as solid state laser. It's the first laser discovered. So it is called solid state laser. And this laser, it was discovered by scientist Myman. He has first developed this laser. Okay. And when we take first main part is active medium, what we'll have in active medium, we are going to take ruby rod. So as you can see in this figure, this part is our ruby crystal. So this is our ruby crystal, and dimension of this ruby, it will be very, very small, students. So here we are not using very big size of ruby, but we are using very small piece of ruby. And what will be the dimension of ruby? So dimension of ruby will be, it is around 0.5 I think 0.5 centimeter dia and around 2 centimeter or 1.5 centimeter so length. So very small piece of ruby rod we are going to use. And if we take this ruby, what is the composition of ruby? Ruby is made up of aluminum oxide. This ruby, it is made up of aluminum oxide and it is going to consist of very small percentage of chromium ions. Very small percentage of chromium is present. And what is the color of ruby? Ruby will appear red in color. So it will appear red in color. And why it is red in color? Because of this chromium. So this presence of chromium, it is going to give its red color. And what, as you can see, there are two types of ions, aluminum ion and chromium ion. But which is going to give us laser light? So main active material is chromium ion. So this chromium, it is going to give us laser light. Main. So main active material is chromium. Okay, so as you can see, I have taken a ruby rod. Dimension of ruby rod is very small, and this ruby, it will appear red in color. So it will appear red in color. Why? Because actually it is made up of aluminum oxide. Into that aluminum oxide, we are going to add very small percentage of chromium oxide. And ruby, it has red in color because of these chromium ions, and these chromium ions are going to give us actual laser light. So this is about the active medium. Okay, students. Now second part is our source of energy or energy source. The second part is source of energy. So if you look at the source of energy, now as you can see, this ruby rod, it is surrounded by this helical tube. So this one, this is called as helical xenon flash tube. Helical xenon flash tube. Okay. Now, what is the shape of the tube? It is helical in shape, and it is surrounding our ruby rod. And this tube, it is filled with xenon gas. So it is filled with xenon gas, and this flash tube, as you can see, it is connected to a power source. When I switch on this power source, what happens? This flash tube, it is going to give us flashes of light. So what is the source of energy? We have helical xenon flash tube. So helical tube, which is so here helical xenon flash tube, and when we switch on power supply, when power supply is switched on, when we switch on power supply, so what this flash tube is going to do, it will give us flashes of light. So it will give us flashes of light. This is just like when we are clicking camera, we'll get flash of light, right? So this source will also give us flashes of light. One flash comes, after some time another flash comes. And when each flash comes, which is going to exist for few milliseconds, each flash, it is going to give us several thousand joules of energy. So we are going to get several thousand joules of energy from each flash. Okay, and that energy we are going to use for pumping. So for pumping process, from where we are going to get energy, we are going to get this energy from helical xenon flash tube, which is connected to power source. Once we switch on power source, this flash tube, it is going to give us flashes of light, and each flash, it is going to emit lot of energy, and that energy, it is used for pumping of chromium ions. And one more thing, what you have to understand here is this ruby laser, it's an example of optical pumping method. So it is an example of optical pumping method. Now optical pumping, where you are supplying energy in the form of light, because here what we are getting flashes of light. When you are selecting energy in the form of light in order to do pumping process, then that type of pumping method, it is called as optical pumping. So this is about the source of energy. Now coming to third part. What is our third part, students? Yes, what is the third part?
Optical
See
resonator.
block diagram of laser system and tell me what should be the third part. Third part of any laser system apart from active medium and source of energy. No one is there to answer today.
Optical resonator.
No? Yes. Who is it answering? And it's not clear for me. Third one is
Optical resonator.
Optical resonator.
What is optical resonator? I think we have discussed in the last class. What is optical resonator?
Two mirrors on either sides of active
What
medium.
is
Two mirrors
optical
on either side of
resonator?
active medium.
So third part is optical. So what we have into optical resonator, we'll have two mirrors. Now in order to have these mirrors, what we'll do here, see here, these are the end faces of ruby rod. This is one end face and this is another end face. What I will do, end faces of ruby rod. These are the two end faces of ruby rod, right? First, they are polished smoothly and they are silver painted in such a way that one end is fully reflecting and other one end is partially reflecting. So I'm not going to go for extra arrangement of mirrors. What I'll do, end faces of this ruby rod, they are polished and they are painted, silver painted. So they are painted with silver in such a way that one end should be fully reflecting and other one end is partially reflecting. And once we get laser light, from which end it will come out? It will come out from partial reflecting end face. From here we are going to get output laser beam. So this is about the construction. So what is the construction, students? We have active medium, and in our ruby laser, active medium is solid state. What is that solid state? We have taken ruby rod, and ruby rod, it consists of majority of aluminum oxide and very small amount of chromium, but chromium only is going to give us laser light, and red color of ruby, it is because of chromium. And what is the energy source? Energy source is this ruby rod. It is surrounded by helical xenon flash tube, and this flash tube, it is connected to power source. Once you switch on power source, we are going to get flashes of light, and each flash, it is going to give us lot of energy, and that energy we are using in order to pump chromium ions. Pumping means in order to move these chromium ions to higher state. And third one is optical resonator, where I should have two mirrors. And here what I'll do, end faces of this ruby rod, they are silver painted and polished in such a way that one end is fully reflecting and other end is partially reflecting. And once we get laser light, from which end we'll get our laser output? From partial reflector. So this is about the construction. Now next is we are going to see what is the working of this laser using energy level diagram. So next, you people copy this energy level diagram. All of you copy this energy level diagram. Working using energy level diagram. So here it is given anyway, right? So this is energy level diagram of ruby laser. So we are going to see working of ruby laser using this energy level diagram. So all of you copy this diagram, then I'll explain you about working of this ruby laser. All of you start copying. Finished? Finished, students? Have you
No, ma'am.
copied?
No, ma'am. 1 minute.
Yes.
Not finished, ma'am.
Okay. Okay. If you are done, just let me know. Then I'll explain what is happening here.
Yes.
Okay, so if it is finished, then I'll start discussing about working of Ruby laser based on energy level diagram. Now, actually, I'm doing it again onto the right side, students. So if you take, actually, this is the energy level diagram of chromium ion. So these are the, actually this Ruby laser, it's an example of three energy level system. Ruby laser is an example of three energy level system. What do you mean by three energy level system? Where we are explaining working of Ruby laser using three energy levels. What are those three energy levels? E1, E2 and E3. Okay. So as I told you, what is the main active material in Ruby laser? Chromium ion. So if I take chromium ion, it consists of three energy levels, students. So what are those three energy levels? First one is, actually you can keep it as G. G stands for ground state. So first energy level is ground state, and there are two excited states. This is first excited state and this is second excited state. First excited state, it is taken as M, which is metastable state. And next excited state is H, which is higher excited state. Okay, so next is higher excited state. Lot of disturbance you are getting now. You are not able to understand what I am saying. Yes, students? Please unmute yourself and let me know.
Ma'am.
Understandable, ma'am.
వినపడుతుంది కదమ్మా, నేను అనేదైతే మీకు వినిపిస్తుంది కదా.
Yes, ma'am.
Sorry. Okay,
Yes,
good.
ma'am.
So here basically we are going to explain working of Ruby laser using three energy levels. That's why we say that it is an example of three energy level system. It consists of three active energy levels. What is the main material which is going to give us laser light? Chromium ion. Okay. The chromium ion lo we have three energy levels. One is ground state, other one is metastable state, and other one is higher excited state. What is metastable state? We know that metastable state is the excited state which has got long lifetime. Okay, and what about higher state? Higher state lifetime is very, very less. So are you able to understand, students? So if you just look at this figure, here we'll say that this metastable state has got long lifetime. What do you mean by lifetime? Duration of time spent by an atom. Okay, and an energy level is called lifetime. And this higher excited state lifetime is very, very less. So this lifetime is less. Right? Okay. Now first, where will be our chromium ions? First, chromium ions will be present in ground state. So chromium ions they are present in ground state. Okay. Now next, what I'll do, I'll switch on power supply. We have seen in construction there is a power supply, right? So I'll switch on my power supply. When I switch on power supply, what helical xenon flash tube will do? It will give us flashes of light. So you'll get first flash. Okay, okay, flash is. When one flash comes, I told you that several thousand joules of energy will be emitted. And what is the wavelength of that flashlight? The wavelength of that flashlight is 5,500 angstroms. Because we are using our energy for pumping as light, light consists of photons. So when these photons come and strike these atoms in the ground state, absorption takes place. What do you mean by absorption? Absorption is excitation of atoms from lower energy level to higher energy level. So once that flash comes, once that energy is released, then what happens to chromium ions? Some of the chromium ions, they'll go from ground state to metastable state, and some of them they'll go from ground state to higher excited state. Okay. So first, chromium ions will be in ground state. Once we switch on power source and once we get flashes of light, because of that flash, these chromium ions, they will absorb their energy and will get excited to metastable state as well as higher state. Now, atoms or ions which have gone to metastable state, they won't get de-excited faster. Why? Because its lifetime is long. But whereas ions which have gone to higher state, their lifetime is very, very less. So within very short time, spontaneous emission takes place. What is spontaneous emission? Where atom or electron in excited state after its lifetime will lose its energy and will come down to ground state. So here now transition of chromium ion takes place from higher state to metastable state as well as from higher state to ground state. Okay, and this emission is spontaneous emission. So what is this? This one is spontaneous emission where ions are coming down after their lifetime. Right, students? Now, what you're going to observe here is first chromium ions they have gone from ground state to metastable state, and some more were added from higher state to metastable state. So a stage will be reached where population of metastable state will become more than ground state, and what is that stage called as population inversion. Are you able to understand, students? So we are going to achieve population inversion. So what do you mean by population inversion? Where population of higher state is made larger than population of lower state. Okay, students. Okay, so after pumping process has gone, we'll have lot of chromium ions in metastable state. Now, we said that chromium ions they may get de-excited from higher state to ground state. Now this is spontaneous emission. That's why we know that during spontaneous emission photons are emitted. So we are able to get some photons because of spontaneous emission from higher state to ground state. So this transition will give us some photons. Whereas this transition from higher state to metastable state is taken as non-radiative. What do you mean by non-radiative? Where energy is not released in the form of photons, but energy is released in the form of heat. Whereas this transition from higher state to ground state is radiative, and that is spontaneous emission, and we are going to get some photons. Okay, now these photons which are emitted, okay, because of transition from higher state to ground state, now these photons they are going to undergo multiple reflections at those two mirrors. I told you what is the working of those two mirrors. Whatever two mirrors we are arranging on either side of ruby crystal, what they'll do, these photons which are emitted during spontaneous emission, they are going to undergo multiple reflections. Okay, suppose this is our ruby rod, right, students? This is our ruby rod. So in that ruby rod on either side, this is fully reflecting mirror and this is partially reflecting mirror. Okay. Right, and here I have excited chromium ions. Here we have excited chromium ions in ruby rod in mark. So these are excited chromium ions. Okay, and apart from that, there are some photons emitted because of emission from H to G. So there are some photons. Now these photons they will travel and they'll undergo multiple reflections at these mirrors. So they'll undergo back and forth reflections. They get reflected from this mirror to that mirror to this mirror. And these photons, during their reflection at these mirrors, they'll go and collide with those excited chromium ions. Suppose one photon, it has gone and strike the excited chromium ion. Then what it will do, it will stimulate the emission of this excited chromium ion onto the ground state. Stimulated emission takes place. And per stimulated emission, how many photons are emitted? 2 photons. These 2 photons, again, they'll undergo multiple reflection at these mirrors and they'll go and strike 2 more excited chromium ions. Now 2 excited chromium ions, they'll come down. So total how many photons? 4 photons are emitted. These 4 photons, again, they'll undergo multiple reflection at those mirrors and they'll go and strike 4 more excited chromium ions. So like this, number of photons will increase in number, and once your photon grows in strength, photon beam grows in strength, from which end it will come out? It will come out from partial reflector. So this is about the working of UV laser. So what is the working? First thing what you have to keep in mind is, what is the active material? Active material is chromium ion, and this chromium ion consists of 3 energy states. One is ground state, then next is metastable state, another one is higher excited state. And metastable state has long lifetime. Okay. And first chromium ions, they are present in the ground state. When flash comes, all these chromium ions, they'll absorb energy and then they'll get excited to metastable state as well as higher state. But ions which have gone to higher state, very soon they'll get de-excited to ground state as well as metastable state. And ions which are coming from higher state to ground state, they'll emit photons because of spontaneous emission. But whereas chromium ions which are getting de-excited from higher state to metastable state, they won't emit any photons. That energy is released in the form of heat. And photons which are emitted due to spontaneous emission, they'll undergo multiple reflections at these meters, and they'll make these excited chromium ions in metastable state come down due to stimulated emission, thereby giving us laser light. And what is the wavelength of laser light that is emitted from ruby laser? Its wavelength is 6943 angstroms. Okay, so this is about the working of ruby laser. Any doubts, students? Any doubts?
No, ma'am.
If you have any doubts, you can ask me. Okay, so now I'm going to discuss about second type of laser. At least construction will take. Of course, time is almost over, but you people try to take construction. So what is the second type of laser? Second type of laser is helium neon laser. Okay. Are you able to see the screen, ma? PPT have changed PPT. Are you able to
Yes,
see?
ma'am. Yes, ma'am.
Yes, ma'am.
So what is our second type of laser? Helium neon laser. I'm going to show
Neon
you
laser.
construction. So take this construction, students. All of you draw this construction in your books. So this is construction of helium neon laser. All of you take this figure, then I'm going to explain about this construction. So next laser is helium neon laser. So this is our helium neon laser, and actually this helium neon laser, it is called as gas laser. Whereas our ruby laser, it is called solid state laser, because their active material we are using is solid material. And here what is the active material we are using? We are using a gas which is mixture of helium and neon. So all of you copy this figure in your notes, then I'll explain you about working of this function construction of this helium neon laser. Okay, students. So once you are done with this figure, I'll again give you what is active medium, source of energy, as well as optical resonator. We'll discuss working in the next class, but at least you take this construction of helium neon laser. All of you copy this in your notes figure.
Confirmation about programs. Then the applications of policy management.
Finished, ma? Have you copied?
No, ma'am.
No, ma'am.
Students, are you done with copying?
No, ma'am.
No, ma'am.
Now, the diagram
So for the timing, we just copy this figure. We'll discuss it in the next class. Because today we have a lot of disturbance now. Okay. So this construction and working, I'll finish in the next class. Application just will have a class. Then I'll make you do numerical problems tomorrow. So from day after tomorrow, I'll discuss question bank. Okay. I think you people got new schedule of CI1 exam. Emma, ఎప్పటి నుంచి ఉన్నాయి CI1?
8th అన్నారు మ్యామ్.
Eighth, ma'am.
షెడ్యూల్ వచ్చిందిగా ఎప్పటి నుంచి ఉంది మనకి? Students, today no one is attentive in the class. Huh?
8th onwards, ma'am.
8th
ma'am.
అన్నారు
No one
మ్యామ్.
is responding properly.
8th అన్నారు మ్యామ్.
Eighth, ma'am.
I think I'll end my class here. We'll discuss it in the next class, students. So you have to copy these 3 main parts also. We'll do it in the next class, okay? So I'll stop my class now. I think now
Okay, ma'am.
next class will be taken by your Python madam. Okay, students?